Okay, so we're going to talk now about water and electrolyte regulation. Okay, so we've got several, actually it's not several, it just looks like it. So we're going to talk about a couple of things, but this all ties into the hormonal regulation of fluid and electrolyte concentration during exercise. So hopefully you remember this from PE 220. So this is the renin-angiotensin-aldosterone system. Okay, so if we've got low pressure, ultimately this is going to increase the release of renin. Renin will then ultimately lead to the increased concentration of angiotensin 2. There's a couple steps that we're skipping there. And angiotensin 2 will go through, notice it has four effects, ultimately increasing mean arterial pressure. Okay, this is due to the long-term control, or this occurs for long-term control. There are other things that we can do, but this is really important, especially when it comes to fluid balance. So when we exercise causes our blood pressure to go up, okay? So how do we do this? Well, the simple way is through what we consider the short-term control of blood pressure. So we increase heart rate, we increase stroke volume, we increase resistance, all of which will increase mean arterial pressure. Okay, so when it comes to exercise, like we said a minute ago, renin will activate angiotensin 2, and angiotensin 2 does a couple of things. One, it causes vasoconstriction, which will increase resistance, and then it also causes the release of ADH, which increases water reabsorption. It won't increase stroke volume, but it will help prevent stroke volume from decreasing. Okay, ADH doesn't cause more water to come into our body. It just causes us to hold on to as much of the water that's in our body as possible. All right, so let's talk about urine volume. All right, so when we exercise, before we exercise, when we're at rest, if we have high pressure, one of the ways that we can alleviate that pressure is by urinating. Okay, high pressure leads to high urine volume. By urinating out that fluid, blood pressure goes down. However, during exercise, we have an increased pressure, but we have a decreased urine volume. Now, why does this happen? Now, when I ask this question, why does it happen, I don't want you to say, well, I don't have to go to the bathroom in the middle of a race. Now, that's true, like no one does. But regardless of whether or not you're in a race or what you're doing, this is the case. It's not because your body's going, oh, I want to run faster or farther or whatever. That's not what's happening. So that's not the physiological reason, okay? And the reason is because if we increase, this is not what happens, but if this were to increase, if we were to have high urine volume, then we'd have low plasma volume, and then we'd have low pressure, and that's not good. And so we have to have a way to increase pressure while also decreasing or at least maintaining typical urine volume or urine production. So how does this happen? There are two ways. And again, we're going back to the urinary section of your physiology class. So we've got the myogenic mechanism, okay? And what this does is this releases blood flow from or into the glomerulus. So that means there's less blood going into the glomerulus, which means there's less blood leaving or less fluid leaving the glomerulus going into your nephron that ultimately turns into urine. Okay, and we'll talk about this specifically in class, but hopefully you can go back to your notes from your physiology class and learn about or remember, it's probably a better way, about the myogenic mechanism. And then the other way is that we increase the release of antidiuretic hormone so that any fluid that does get into your nephron, we're pulling most of that back. Now, that's the water balance. Now we've got sodium, and sodium and water are tied together. Okay, oftentimes sodium's used to maintain plasma volume because water follows salt. You create a gradient. Water will go from a low concentration to a high concentration to try and balance out the osmolarity. So if we have high sodium, generally we have high plasma volume. And the way we have high sodium is through the hormone aldosterone. Okay, and so as a result, having a high salt concentration will help us maintain plasma volume. However, we can mess this up or we can alter this. Okay, when you exercise, you sweat. When you sweat, you lose water. And yes, you do lose some salt, and depending on, there's a couple of factors here, depending on how dilute or concentrated your salt or your sweat is, what happens to your sodium concentration. But generally speaking, if you sweat, you lose plasma volume, but you increase your sodium concentration. Now, remember, this is concentration, not the amount of sodium. Those are two different things, okay? And so if I've got high sodium concentration, that's not great either, all right? And so we want to get sodium concentration just right. But if I've lost water, how do I do that? Well, I can release aldosterone, okay? So by releasing aldosterone, by decreasing the amount of aldosterone. Remember, aldosterone causes me to hold on to salt. Well, if I decrease the amount of aldosterone, then it's easier for me to get rid of sodium, okay? And so I can get rid of sodium through my kidneys, but I'm going to want to hold on to that water. So in this case, if I've got a high sodium concentration, I'm going to reduce my aldosterone, but I'm going to increase my ADH. So ultimately what's going to happen is I excrete more sodium, but I hold on to more water. All right, and this results in a reduced sodium concentration, hopefully getting us back to normal. Okay, we're going to talk about this in the next video, but it's really important that we maintain the concentrations of different ions and even your like your hematocrit, your blood cell concentration. And so it's vital that we have the correct concentrations. All right, so at the end of this lecture, can you do the following two things?